So in 3.4, we will focus on the slope, and we will just skip the last objective, a slope as a rate of change, because in that topic we will just talk about some application problems. We will focus on A, B, C, D, the first 4 objectives, and skip the last one. So let's start with the first objective. The first one is how to find the slope if we are given 2 points on the line. Okay, so first we know the definition of slope. The slope is if we have a straight line, and the slope is the steepness of the straight line. The steepness of the straight line. And we will focus on how can we get the slope. And the slope here, we will just use the letter M to denote the slope. So by the definition, it is we can find the definition by check this formula. It's just the change in y, so vertical change. Vertical change is our numerator, and change in x. So here is horizontal. The denominator is horizontal. Make sure you don't mess up. So the top will be changed in y, and the bottom will be changed in x. So that ratio is our slope. Let's check the example to help us understand how can we find the slope if we have 2 points. So the example here is just like here. If we have 2 points, the line through this is our first point, and this is our second point. This is our 2 points. We given this 2 points, and we want to find the slope of this line. Let's see, how can we get the slope M? M is the notation of slope. So by the definition, we know if this is point 1, or let's say point A or anything else, and this is the second point, we want to find the change in y. So we find 5 is changed to be -3. So if it's our start point, this is the ending point. So we will use -5. We change the point from 5 to -3. So use -5. -5. Similarly, we know the x value from -1 to 2. So 2 minus -1. Okay, we use -3 minus 5 and 2 minus -1. If we set this one will be the first point and this one will be the second point, or we will say this is the start point, this is the end point. Okay, then we only need to get the value. So here it will be like this. We will get the slope if we are given 2 points. Or you can think this one is our x1, y1, so this is the first point. There will be x2, y2. We use y2 minus y1. Make sure you use y2 minus y1 and x2 then minus x1. Okay, start with the same point and with the same point. Use the end point y2 minus start point y1 divided by the end point x2 minus the start point x1. So we will always get this formula. We want to get the slope, then we use y2 minus y1, x2 minus x1. Make sure you know x2, y2 is one pair, x1, y1 will be another pair. So let's check another example. This time, let x1, y1 to be the 2, 4. We know this is our start point. Let's say x2, y2 be another one, -1, -2. Okay, if we want to find the slope n, what should we do? Remember, we always use the end point y2, the y for end point. So that will be this one is our y2, right? x2, y2. So we use y2 minus 2 minus y1. Y always minus y, okay? X minus x, but y2 minus y1. So here, x1, y1 minus 4. Similarly, x2 minus x1. So x2 minus x1. Then solve this one. We will get -6 over -3. We will get 2 as our slope. Okay? So how can we solve the slope? Make sure, remember, we always use, if here is y, the top part is always y, and the bottom part is x. So this means the y for the end point minus the y for the start point. X for the end point minus the x for our start point. So that's change in y divided by change in x. Change vertically divided by change horizontal. Okay. And from the graph, these two examples, we realize it's possible to get a negative slope, right? And sometimes it's negative, and sometimes it's positive. What does that mean? We will have this conclusion. If this is our straight line, this is our straight line, okay? So we will say this straight line goes down. Then the slope is negative. Negative slope goes down if the straight line goes down. So for this one, if the straight line goes up, then the slope we know is a positive number. So for our first example, we get a negative slope. So it must goes down. So like this way, goes down. And for the second example, we get a positive slope. So the curve must goes up. So now let's check the second objective. This time, we still want to find the slope. We still need to find the slope. But this time, we do not have 2 points. We have the equation. we have an equation. We have the equation. How can we get the slope m? So it's still almost the same procedure, but a little bit different because we are not directly have 2 points. But we know if we want to get the slope, we need 2 points because we want to find the change in y, then divided by the change in x. So we need 2 points. So we only need to use that equation to help us find 2 points first. Use the equation, find the 2 points. Then the remaining part will be just the same as previous topic. We only need to do one more step. First, we need to find the 2 points by the given equation by ourselves. Then we need 2 points. We use these 2 points to find the slope. So let's check. Let's check the example to help us. If this time we have this equation, we have this equation. Oh, okay. We have actually, before we check this example, let's talk about another special form of the line equation. We already learned the standard form of equation there, right? This is the standard form of equation. But when we talk about the slope, after we learn what is the slope, we will have another form of the straight line. So we call it slope-intercept form. So we can change the straight line equation to be this kind of form. We put y on the left side, then y equal to mx plus b. If we can change our standard form to solve for y, something like solve for y, then we will automatically get the slope of this straight line. And the slope is just the coefficient of x. So again, this first form, we call it a standard form, right? Standard form, if we use this standard form, we switch to another form. Just like we use the equation to solve for y, we put y on one side. Y is equal to something. And this, from this equation, we will see the coefficient of x is just the slope. The coefficient of x is the slope. So this is called the slope-intercept form. Let's check the example. So we have this. So we have this kind of equation. This is the standard form. We have 2 ways to solve for this equation, right? The first way, we could just use, so this is the way, change this, and you can find the 2 points. 2 points. Let's see, we have 2 different ways to help us find the slope. We'll see the solution 1 is try to transform the standard form to the slope-intercept form. then we can directly find the coefficient of x is just our slope. Of course, another way is, just like I said, we only need to find 2 points by this given equation. Then we can use 2 points to help us to find the slope. Let's first try the first way. So this time we want to solve for y. So how can we solve for y? We put y on this on one side and set x to another side. Then we divided both sides by 3 to get 11 over 3 plus x. Then we just switched order to make it like the slope intersect form, and we know the coefficient of x is just our m. So from here, we use this standard form of the linear equation. We solve for y. Then we only need to find the coefficient of x is our slope. Of course, this is one way. We could use another way if we want. So we still have the same equation. Right? We need to find the 2 points. How can we find 2 points? We can set x equal to 0 if we want. First, we can use the first point, point 1. X equal to 0. Then we know, so for y, we use 0 to replace x. We will get this term. 3y equals 11. So y is equal to 11 over 3. Then we write this pair. 0, 3, 11. Right? Point 2. We set to x equal to 1. Okay, then we use 1 to replace x. So for y. So we will get 3y equal to 13. Y is equal to 13 over 3. So this time we have the second point. 1, 13 over 3. Then we could use 2 points, these 2 points, to find it. Remember, how can we use 2 points? y2 minus y1 divided by x2 minus x1. So in this case, this is our second point, right? If you set this one as your second point, you could use 13 over 3, y2 minus y1, minus here 3, right? So this will be your x2, 1 minus 0. So we will get, so the denominator will be 1, so it's just 2 over 3. So this is another way to help us find the slope. Okay, so you will have 2 ways to solve for the slope. Again, the first one, you can change the standard form to the slope intercept form. What's the slope intercept? This is called the slope intercept form. So, or you can treat it as solve for y. Solve for y, right? Y is on one side, the remaining part on the other side. So that's solve for y. Then after you solve for y, you can automatically find the slope. It's the coefficient of the x term. So that will be the slope. The second way is just find the 2 points based on the equation. So we can randomly pick 2 points. After we find these 2 ordered pair, make sure you use this equation, y2 minus y1 over x2 minus x1 to get the slope. Okay. So that's the second objective. So objective C, we could find the slope of horizontal line and the vertical lines. So it's based on some examples. Let's see if we have this line equation, y is equal to some value. Remember, if it's y equal to some value, from purest section we already know y is equal to value. So y is a fixed number. We will draw this curve like a horizontal line. So it's a horizontal line. Y is equal to something because y is equal to a value is parallel to the x-axis. It's a horizontal line. Let's see. If this is a horizontal line, how can we get to the slope? By the definition, change in y. Let's see, delta y be delta x, which means change in y, but divided by change in x. Y for any point in this straight line, is there any change by y value? Of course not, because y is a fixed number. So we will realize delta y is always equal to 0 because it's a fixed number for y. Y, no matter any point in this straight line, y value is always -1. So there is 0 for change in y. And it doesn't matter. We will always get the m value equals 0. So for any horizontal line, the slope is always equal to 0. Always 0. Because we know y is a fixed number, so there is no change in y. So the numerator is equal to 0. Then we will always get 0 as our slope. Okay, y equal to something is parallel to the x-axis. So it's a horizontal line. If it's horizontal line, we know the slope is equal to 0. Let's check another one. This time we will have this equation. X is equal to a fixed number. X is equal to a fixed number. So let's see here. So we know x is a fixed number. If we draw the curve, it will be like a vertical curve. X is a fixed number. So no matter what's the y value, right? X is just the same value. So let's check the definition. So we know the top should be the delta y, right? The change of the y value. But how about the denominator this time? It's change in x, right? Change in x. But we realize, is there any change in x value for this kind of line? X is equal to 5. X is a 5 number, so no matter what kind of y, the x will not change. X is always 5. It's a fixed number. So this case, the denominator, the bottom, will always be 0. So what's our conclusion? Undefined. We will say this is undefined. Because because the denominator cannot be 0, right? If the denominator is 0, then it's an undefined number. We will say this vertical line is x equal to 5. And for any vertical line, the slope is undefined. The slope is undefined. X equals a fixed number, then that one will be a vertical line parallel to the y-axis. Y-axis. So it's a vertical line. For any vertical line, the slope is undefined. We already talk about the reason, because this is equal to 0. There's no change in x. So we will have different kind of slope. Let's give it a summary. We have 4 kinds of slope. Remember, the first one we said it's upward. Upward, then m is a positive number. Upward goes up, right? Upward. This is the first one. Let's see. We of course has the second one. Let's see if it goes down. Goes down, downward. Goes down. Then we will get a negative slope. But we sometimes will have a horizontal line, okay? Different horizontal line, it will be y equal to a number. This is also a y equal to a fixed number, right? So for this horizontal line, m is 0, the slope is 0, horizontal line. Of course, we have another special case called the vertical line that will be x equal to a fixed number. If x equal to a fixed number, then it's parallel to the y-axis, it's vertical line. Then m is undefined. Or we will say no slope. Because it's undefined, then we can call it no slope. They are the same meaning, okay? M is undefined, we can call it no slope. So that's just talk about the slope of horizontal line and the vertical line. You just need to memorize horizontal line, 0 slope. Vertical line, no slope. Let's check. Objective D. We will talk about 2 straight lines parallel to each other or perpendicular to each other. Parallel or perpendicular to each other. How can we find these 2 lines are parallel or perpendicular to each other? So we have this rule. If they have the same slope, so parallel, we have this rule. Of course, first, if they have slope, so that means cannot be vertical lines, right? Any vertical lines, they do not have slope. So if they have slope, they have the same slope. So first condition, they have the same slope. The second condition, different y-intercept. So what does that mean? Remember we talked about this one. It's called slope-intercept form. Why this one is called a slope-intercept form? Because from this equation, we will know the coefficient of x is automatically the slope of the equation. And we can also directly find the value of y for the y-intercept. So that will be, we can automatically get to the y-intercept because we know x equal to 0 and y is equal to b. It's just the y-intercept. So this one called a slope-intercept form because we can directly find the slope and the y-intercept based on this form. So we go back to check the conditions. Same slope, which means m should be the same one, but b is not the same. Then we call these lines are parallel to each other. So for example, we have these two lines. So we check the conditions if they are qualified. So first, do they have the same slope? So we know the coefficient of x in this form is the slope. So both are -2. So the first condition is qualified, right? Same slope. Then we check different y-intercept. So different y-intercept, it's +4 and it's -1. They are different. So we will get the conclusion. Yes, these two are parallel to each other. But some student will ask, we have the second one is called a different y-intercept. But if they are just the same, what will happen? What's our conclusion? If same slope and same intercept, then these two lines will be exactly the same. So that's just the same line. We cannot say it's perpendicular or parallel for the same line, right? If these two, the first one is same and the second one is different, then there will be two different lines. Then we can say these two parallel to each other. Of course, another special situation is if we have two horizontal lines, like x equal to 3, x equal to 5. We know this vertical line, right? X equal to a value. Vertical line, x to another value, still vertical line. These two vertical lines are of course parallel to each other, but they do not have slopes. They both do not have slopes. Vertical line, vertical line. Okay? Let's check perpendicular. When we can say two lines are perpendicular to each other, let's see. Two vertical lines are of course parallel to each other. Talk about perpendicular. The slope, the product of the slope of, so if we have the slope for the first line and we also have the slope for the second line, and we realize the product of these two slopes is -1, then we will say perpendicular to each other. This is the general case. Okay, this is the general case. If we have two lines, we can determine if they are perpendicular to each other only if this one times this one get -1, the product negative. Of course, we have another special case is something like we know x is equal to some value, is a vertical line, right? And this is a horizontal line. These two are, of course, perpendicular to each other. One has the zero slope, another one is no slope. This is the special case. The general case, we have the slope for both lines. So the product of these two slope is equal to -1. Then we can say they're perpendicular to each other. Let's check. If we have this line, and this line. So based on these two lines, we know they have slope, right? The coefficient for x is 4. So this is m1. And this is our m2. So first step, we already realized they are not the same number, so they will not be parallel to each other. Then we check if they can be perpendicular to each other. We only need to find the product of this two slope, m1 times m2, right? We will get -1. Okay. If we get -1, so we will get to the conclusion. Yes, these two lines are perpendicular to each other. Okay. So first, when we have two lines, we check if they have the same slope. If they have the same slope, we check if they have the same intercept. If they have the same slope and the same intercept, then they're just the same line. If they have the same slope but a different intercept, then they parallel to each other. But if these two slopes are not the same number, we could test if they are perpendicular to each other. We check the product of these two slopes. If the product is equal to -1, then we can still get the conclusion they are perpendicular to each other. So that's the basic step to determine the relationship between two lines, right? But for perpendicular, we have the special case is one vertical line, one horizontal line. Just like we have the special case for the parallel case, there are two vertical lines. Of course, we can also have two horizontal lines. This means two horizontal lines. Two horizontal lines. Two vertical lines are parallel. Two horizontal lines are also parallel to each other. Let's check the example. We have several pair of lines. So we want to know the relationship. For example, we have this one first. So this, for easy to get the conclusion of a parallel or perpendicular, we need to check the slope and the intercept, right? So the slope-intercept form will be helpful for this situation. So if we have this, the first equation is already the slope-intercept form, but the second one is not the slope-intercept form. So we need to switch it into the slope-intercept form first. So for this one, let's see. We work on the second one first. We solve for y to switch the standard form to be the so y equal to -2. plus 3 over 10. So now we rewrite the two equations we have. So we copy the first one, then pick the slope-intercept form for the second one. Now we check these two lines. First step, we work on the slope. We realize they have the same slope. That's good. Right, they have the same slope, so we can check next step. What is the intercept? And the first one we have positive 1, and the second one we have 3 over 10. They are different. So what's our conclusion? Same slope, different intercept. They are parallel to each other. Let's check another one. This time we have so these two are not slope-intercept form, right? We need to switch them to slope-intercept form first. So for the first one, we can get this negative x plus 3. That's the slope-intercept form. And the second one, we can switch it to x plus 4. This slope-intercept form. Then we check the slope of these two equations. We realize for the first equation, what's the coefficient of x? It's not 0. It's negative 1, right? Because it's negative 1 times x, we just drop the 1. So it's the negative 1. So m1 is equal to negative 1. How about the second slope? The second slope, it's not 0 too, it's 1. So first step, we check these two slopes. We realize they are not the same. Now we want to test. If they are not the same, we see, is that possible? They are perpendicular to each other. So we only need to get the product of these two values to see if the product is equal to negative 1. If it's negative 1, then we can say these two lines are perpendicular to each other. And for this case, it's just negative 1. So what's our conclusion for these two lines? We will say these two lines are perpendicular to each other. Are perpendicular to each other. So let's see the part C, example part C. So first step, we still need to switch the standard form to the slope-intercept form to help us. So for the first one, we will get this as the slope-intercept form. And this one, we will get negative. As our slope-intercept form, where we just solve for the y. We will get the coefficient of x is the slope. So the slope 1 is negative 3 and slope 2 is negative 2 over 3. And first, we compare these two slopes. They are not the same one. So they will not be the perpendicular, will not be the parallel to each other because they are not the same number, right? Then we check the product of these two to see if it's equal to negative 1. So in this case, we got it's just 2. It's just 2. Is not equal to 1. So m1 is not equal to m2. And the product is not equal to negative 1. So our conclusion is neither. They are neither parallel nor perpendicular. Neither. Okay? So that's for the parallel and the perpendicular. Of course, we know sometimes we have special cases. Again, if you have two vertical lines, just like x equal to 3, x equal to 5, something like x equal to one number, x2 equal to another number, which means these are two vertical lines. Two vertical lines are parallel to each other. Or you have two horizontal lines. Okay? So something like y equal to 3, y equal to 1, then they are horizontal lines. Horizontal lines are or parallel to each other. Of course, sometimes you have vertical lines like x equal to one value, and you have horizontal line y equal to another value. Of course, horizontal line, vertical line, always perpendicular to each other. Okay, this is the special case, and we use slope to solve the general case. So that's for 3.4.